All right, here are some more problems that we have for Algebra 2. So we're going to divide 2x cubed minus 2x plus 4 by x plus 2. So we are going to have to fill in the blank for a missing value here because we have to have the exponent for whatever the highest x exponent is. We have to have a term for each exponent between that one and 0. So what I mean by that is we've got 2x cubed plus, we don't have anything x squared, so it's going to be 0x squared because 0 times anything x squared is going to be 0. So it doesn't change the value of this. It just puts a placeholder in there for us. Now we have 2x, and that is to the 1. And then plus 4, that is x to the 0, because x to the 0 would be 1. 4 times 1 would be 4. So whatever the highest exponent is, all the way to x to the 0, which is just a whole number by itself. Now we're going to divide this by x plus 2. So x plus 2. We are going to look at the x term and divide 2x cubed. So 2x cubed divided by or reduced by x would leave 2x squared. And I like to write it over the matching exponent just because that's the way my brain is organized and it helps me see when I'm done faster. That's just a thing that I do. A lot of people do that. It's okay. Now that we know, because we canceled an x from here, right? We took this up to the top. That was x negative 1, which gave us 2x squared, right? So 2x squared times x is 2x cubed. 2x squared times 2, because we have to multiply by the second term, is going to give us a positive 4x squared. Now, in order to make these cancel, we have to change the sign. So we change it from positive to negative. These two will now cancel, becoming 0. And 0x squared and a negative 4x squared becomes a negative 4x squared. We bring down our next term. Now we're going to divide negative 4x squared by x, which is our first term. And if we bring this to the top, x negative 1, this becomes negative 4x. So that's what goes here, negative 4x. Now we multiply negative 4x times x. It gives us a negative 4x squared. We multiply negative 4x times 2. We get negative 8x. Now we change the sign in order to make these cancel. So these are now opposites. And we have negative 2x plus 8x, which gives us a positive 6x. We bring down the next term. Now again, we're going to divide by x. So 6x divided by x, this would come to the top and be x to the negative 1. This is a positive 1. So that would just be 6 by itself. So plus 6, because that's a positive 6. 6 times x is 6x. And 6 times 2 is a positive 12. But now we change the sign to subtract to cancel this out. Positive 4, negative 12 leaves a negative 8. We have no other terms to bring down, so this is our remainder, minus 8. And this still has a remainder. It still has to be divided by the divisor. So we write the divisor underneath it to show that that division has not happened. That's all we have left to do. So we have to finish dividing it, but we can't because we have an unknown here. If we knew what that number was, we could finish dividing negative 8, but we don't. So that's all we can do. And that would be your solution. 2x squared would be one term. Negative 4x would be another term. Positive 6 would be another term, the third term. And then negative 8 over x plus 2 would be the fourth term. And that'd be how you would solve a problem like this. Let's look at the next problem. I feel like I've already done this problem, but I can't say for sure, so I'm going to go ahead and redo it anyway. So we know if this is a straight line, which it is, and this is 150, then this has to be 30. And we also know that these are going to be congruent angles. Like this is going to be congruent to this one. This will be 30. So that means this one will be 30, which means that this one is 60. So we have a 30-60 triangle going on right here. So we can use SOHCAHTOA. We just need to find M. We don't need to find P. So I need to find the adjacent. So we're going to use the sine of 30. And that is going to be equal to the adjacent over the hypotenuse of M. So I can multiply both sides by M. I get M times the sine of 30 is equal to 2, which doesn't tell me anything because I can't do anything with that. So I'm going to divide both sides by the sine of 30. That cancels. So now I can solve for M. 2 divided by the sine of 30 degrees. If I pull that up and get my big calculator out, I can say 2 divided by, and in parentheses I can find the sine of 30. And that's going to equal 4. So M is equal to 4. All right, so that is the value of M. Because the sine of 30 is 0.5, I do believe. So 2 divided by 4 would be 0.5. All right, so let's look at the next problem. So here we've got an estimation problem. Remember, estimation problems are just horrible. I say that, out of a true appreciation for the fact that when we estimate, basically estimation problems just show you how wrong, how bad people are at estimating. So that'd be 7.468, which we would round to 7, right? Times 10, and we have, this is 1, 2, 3, 4, 5, so it'd be plus 5, so it'd be to the 19th power. All right, that's the first number. And then we have 7.0, so that would be a 7 also, times 10. 1, 2, 3, 4, 5, plus 5, so it'd be to the 9th power there, over 5 times 10 to the 1, 2, 3, 4, 5 to the 5th power. So 7 times 7, that's going to be 49, times 10 to the 9 plus 9 is 18, so it'll be 28th power, over 5 times 10 to the 5th power. Well, we can't have 4.9 or 49. It has to be formatted differently, right? But just for funsies, we're going to leave it like that and go ahead and divide. So if we do that, we say 49 divided by 5. That's going to give us 9.8. All right, 9.8 times 10. This would be -5, so that'd be to the 23rd power. We can't leave it at 9.8. We need to round that up. So that would be 10 times 10 to the 23. We want to make this one number because the whole point of not having a decimal is because we're estimating. You have to remember the point of the problem, and the point of the problem is to not have any decimals. So we're going to add 1. So that's going to be 1 times 10 to the 24th power. That's going to be your answer there. So 1 goes in this blank right there. Okay. All right, if we had estimated this, right, and moved this over, that would be 4.9 times 10 to the 29th power. This would have been rounded to 5. So it would have really been 5 times 10 to the 29th power over 5 times 10 to the 5th power. 5 divided by 5 is 1 times, that would be to the -5, 10 to the 24th. So you've gotten the same answer regardless, as long as you remember the fact that we are estimating so we can't have a decimal here. Okay, you would have had to have round that up. All right, so next problem. All right, the other two problems that were on the list, I remember doing those. They're in the previous video, so you can go back and watch the video for those two. I don't remember doing this one. So let's look at our points here that we have in order to find our equation of the line. Remember, it's supposed to be y is equal to the slope, the x value, plus the y-intercept. So here I see the y-intercept is 0, positive 9, and we have another point here that is -3, 0. So we have the x-intercept and the y-intercept. So we could easily find the slope here. We've got, if we go up 9, so it's 9, and we go over 3, so 9 over 3 would equal 3. So that's our slope. So y is equal to a slope of 3 times x, and we intercept at the positive 9. That's going to be your solution. All right, let's look at the next problem. All right, so we're going to find B, C, and M here. All right, so we've got 120. We know that this is going to be a straight line, 120. So this has to be 60. So B is 60. C is going to be 30, because 60 and 30 make 90. All right, so now all we have to do is find M. That's we're going to use our SOHCAHTOA and figure out which one we want to use. So M is going to be opposite of 60, and we have a adjacent side of 10. So we need the opposite and the adjacent because we don't have the value of the hypotenuse. So we're going to use the tangent, opposite and adjacent. So the tan of 60 is equal to the opposite M over the adjacent 10, which means 10 times the tan of 60 degrees is the value of M, or the length of M. So we just pull up our calculator, and we're going to do what's inside the parenthesis first. So 60 tan, and then times 10. And we're going to round that to two places. It'll be 17.32 is the value of M. Okay. That is what we're doing right there. 17.32 would be your solution. Let's look at the next problem. All right, so here we're going to convert 400 yards per second to miles per hour. So 400 yards per 1 second. And we want to go to miles per hour. So first let's convert our unit of length from yards to miles. So first I'm going to go back to feet because we don't give the unit of measure of yards in miles. Saxon does not use that. He always goes back to feet. So we're going to say there is 3 feet in 1 yard. That converts yards to feet. Then we're going to go back from feet to miles. There are, in 1 mile, there's 5,280 feet. That cancels the feet. Now that we're in miles, which is where we wanted to get to, we have to convert our time from seconds to hours. So times 60 seconds is 1 minute. That converts seconds to minutes. Now we want to go from minutes to hours. So 60 minutes is 1 hour. So now we are in hours, miles and hours. So our solution is going to be 400 times 3 times 60 times 60 over 5,280. And this is going to be miles per hour. That's going to be your solution. just like that. And if it doesn't take that, then try doing 403, 60, 60 or 60 square over 5280, and then miles per hour separately. That's the only other way I think it would take it, but I'm pretty sure it's in the same fraction. Let's look at the next problem. All right, so if two inscribed angles in a circle intercept equal arcs, the angles are equal. So think about that for just a moment. If you have two angles that intercept the same arc or equal arcs, then the angles are equal. And what that means is APB and ARB are equal because they both intercept arc AB. This is the opening between this angle and this angle. I'm going to use my highlighter to show you what I'm talking about. Let me see if it'll allow me to change it or add. All right, we get a marker here. I'm going to make it really, really light so I can show you what I'm talking about. So this right here, this angle is the same as this angle. Can you see that? Is that dark enough? I don't think that's dark enough. Let me make that a little bit darker so you can see it. About like that. Okay, so you have APB, and they both have the same arc right here. This arc right here, arc AB, that part of the circle, it's 50 degrees. So that means this angle APB is 50 degrees. So X is 50 degrees. Right? And the same is true for angle ARB, right? ARB is the same arc here. Right? Actually, I take that back. It's not 50 degrees. It is going to be where's my here we go. It's half. It's half. I'm sorry. It is half the arc. So this X is equal to 25 degrees because it's half of 50. So this is 25. And this degree here, ARB, M, is going to be the same thing. It's 25 also. So M is also equal to 25 degrees. All right, so you got 25 and 25. All right, this one is 120. This is a vertical angle, so this is 120 also. So that means that angle Y and angle Z have to be the same thing because these make triangles, right? And together 25 and 120 is 145. And we know in a triangle the three angles have to equal 180. So 145 from 180 leaves 35. And Z has to be the same thing because these are 145 also. So this has to be 35 and this has to be 35. That's just the way it's going to roll. We didn't really have to do a whole lot of math to get there. We just had to remember our formula for an inscribed angle. When you have an inscribed angle, that equals half the intercepted arc. So the arc was 50. So in this case, angle APB is equal to half of 50 degrees. which equals 25 degrees. And since angle APB is equal to angle ARB, their X and M are both equal to 25 degrees. All right, which meant, because of the vertical angle here, that Y and Z were also the same thing, which was 35. And 25 and 35 added together is 60. 60 and 120 is 180. So that's another way you can check and see. Just add those together, make sure they're 180. Add these together, make sure they're 180. They are. So these are all correct. All right. It's not hard if you remember the properties. The math itself is not difficult. It is the logic that you have to remember that is going to give you the rules of geometry that's going to give you the answer. And that's where people get caught up, is they forget. Just like I did for just a moment, I forgot that it's half, not equal. So if you have a place where you write down your formulas, write this one down. An inscribed angle is half the intercepted arc. Write it down so you won't forget. All right, and sometimes it helps to write a little illustration there so that you can remember that too. Let's look at the next problem. Okay, we're going to change 28, the length of 28 at 310 degrees to rectangular coordinates. So first of all, we have to remember where 310 degrees lives. So here's our Cartesian coordinate system, right? And we remember this starts at 0, and this is positive side, and this goes all the way around. This is 90 degrees. This is the positive side of the y-axis. Now we go around another 90 degrees. That's 180 degrees, but it is the negative side of the x-axis. We go another 90 degrees, and we're at 270 degrees. That's the negative side of the y-axis. We go another 90 degrees, and this is also 0 and 360 degrees at the same point. That is a full circle, right? 360 degrees in a circle, which is why perpendicular lines make 90-degree angles, because we divide the circle in fourths. 90, 90, 90, 90. Okay, so we know that 310 lives somewhere between 270 and 360. So what we're going to do is we're going to subtract from 360. 360 minus 310 is 50 degrees. We are going to start right here at this 360 and go backwards 50 degrees. So this is 50 degrees right here. And this is the length of the hypotenuse is 28, or the length of this vector is 28. This is the point where we live. Now, we have to be relative to the x-axis. So we're going to draw our line from the x-axis down to that point, which is the reason why I subtracted from 360 and not 270. You always want to be relative to the x-axis, not the y-axis, right? Because the x-axis is what we begin measuring from. That's why it matters so much. So 50 degrees is our angle, and we have a hypotenuse of 28. This is going down below to the negative side of the y-axis, so this is going to be a negative. It's the opposite of up. Negative u is the opposite of up. And this is to the positive side of the x-axis, so it's to the right, right? It's a positive number to the right. So we are going to use these values with SOHCAHTOA to find what's going on. So 50 degrees, we have our hypotenuse of 28. So in order to find negative u, this is the opposite of 50 degrees. So the opposite with the hypotenuse value is so. So we would say the sine of 50 degrees times 28 is equal to negative u. And all I did to get here was I started with the sine of 50 degrees is equal to negative u over 28 and multiplied both sides by 28. But I skipped that step in my head and went straight here. Because once you do this, then you get this. Once you multiply both sides by 28, you get the hypotenuse times the sine of 50 is equal to the length of the side. So now all I have to do is this calculation, right? So we pull up the calculator, we do that calculation, get our scientific calculator out, and I'm going to say what's in the parenthesis first, 50 sine. Then I'm going to multiply times the number on the outside. And then I'm going to round this to two places, so 21.45 is equal to negative u. We don't want a negative variable, so we multiply both sides by negative 1. So negative 21.45 is the length of u. And that's how we would write that. Now we're going to find the length of r. This is going to be the adjacent side to the 50-degree angle. So we're going to use cosine. So again, 28 times the cosine of 50 degrees is equal to r. And I skipped this step right here where it was c equals a over h, and just went ahead and multiplied by the hypotenuse to get my 28 times the cosine of 50. Now all I have to do is, again, pull out my calculator, and I'm going to do what's in parentheses first, 50 cosine. Now I multiply it times my hypotenuse of 28, and I get 17.99. If I round this up, I get 18.00 is the value of r. We keep the r there, so the rectangular coordinates are going to be 18.00 r minus 21.45 u. That is your answer. All right, if you have any questions about that, let me know. I know this kind of throws people off because it was 17.99 and you just want to write 18. But we're doing everything in 2 decimal places, so we keep the 2 decimal places. You want to have consistency, right? Everything formatted the same. So don't let that make you get a wrong answer. Give me the 2 zeros. Next problem. All right, the 2 triangles here in this figure are similar. They're similar triangles. And we're going to use R, S, T, and V to write a proportion. Then solve for r in terms of s, t, and v. So we have to line up the sides that correspond. So we just have to mark equal angles first. So if this angle is equal to this angle, right? We know these are vertical angles, so that means these correspond or are congruent to each other, which means that these have to be congruent to each other because they're the only angles left. Now we can see which sides are congruent to which side. So this is angle 3 and angle 2 is equal to angle 3 and angle 2, so it's the same side. Remember, when writing proportion, we keep the same things together. So the same sides, and then S is angle 1 and 2, V is angle 1 and 2. So on this triangle, the left triangle, we have R and S, and on the right triangle, we have T and V. So the left triangle, the right triangle, angles 2 and 3, angles 1 and 2. All right. Now we're going to solve for R. So to get R by itself, we have R divided by S. So to get rid of that, we're going to multiply everything by S. Right? So the S's would cancel. R is equal to, in alphabetical order, ST over V. That's your solution. That's all we're doing. Okay, next problem. All right, we're going to find m. So we need to find a common denominator first. So our common denominator is going to be x times m plus z. So we're going to multiply each term by what is missing from the denominator. So m plus z over m plus z times ay over x. Plus, this one's missing the x. So x over x times c over m plus z. And this is missing all of them. So x times m plus z over x times m plus z times s over 1, because it is a whole number by itself. Now we're going to distribute, and we can cancel the denominator because all the denominators are the same. So what we have is ay times m plus z plus cx is equal to sx times m plus z. That's what we have. In order to get m by itself, we're going to have to distribute. So we have AMY plus AYZ plus CX is equal to MSX plus SXZ. And I've just written everything in alphabetical order to make it easier for us all to get the same answer. So I see I've got this term here. And honestly, it would be a whole lot easier to just bring this one over here and this one over here. It's moving fewer terms. So you always want to think about how many terms do I have to move to get all of my like terms together, or all my terms with the letter I'm looking for together. If I move this one over here to get it with AMY, then I have to move these two. That's a total of 3 terms being moved. But if I move this one over here, that's 1 term. I only have to move this 1 term. So that's 2 terms. So it makes more sense to move this one and then just move this 1 from here. So that's going to give me AYZ plus CX minus SXZ is equal to MSX minus AMY. Now I can factor. I've got AYZ plus CX minus CXZ is equal to M times SX minus AY. Divide both sides by this factor and I get AYZ plus CX minus SXZ over SX minus AY as the value of M. This is what you would type in. All right, next problem. All right, here we are. We're going to change this to rectangular form. We're going to do the same thing that we did before. In fact, it lives in the same quadrant. So I'm just going to go ahead and draw just that one quadrant. So this we know is 0 or 360. And this one is 270. So we know 325 lives somewhere below 360 back this way. So I'm just going to say 360 minus 325. That's going to be 35 degrees below 360. So 35 degrees in here. And it's going to have a length of 40, whatever it is. That's the point that we're at. So this is a picture of this vector and its location. So we're just going to draw a straight line from the x-axis to the point. It's below on the negative side of the y-axis, so it's the opposite of up, which is down. But it is to the right of the y-axis, so it's a positive r. If it ever goes to the left, left is negative r, which is the opposite of right. It's the way we think about it, right? Okay, so now we just do the same thing we did before, and we can skip the first step. I just write so and ka up here to remind myself of which side is the R and which side is the U. So when I'm thinking about 35 degrees, the adjacent side is R. So that would be the hypotenuse of 40 times the cosine of 35 degrees is equal to R. And then the hypotenuse times the sine of 35 degrees is the negative U. And then I just use my calculator to go from there. So I do what's in the parentheses first, 35 cosine. Now I multiply times 40. Round it to 2 decimal places. That'll be 32.77 is R. And then I do this one. I say 35 sine times 40. And that is 22.94 is negative U. We get rid of the negative sign on the U. Negative 22.94 is a positive U. So that's how we write it. We write it RU XY, because this is the value of the X and this is the value of the Y. 32.77 R, excuse me, minus 22.94 U. That's your solution. All right? Those should get easier because they follow the same formula every time. You figure out where the vector lives, and then you draw a dotted line to the x-axis. And then you use your cosine and your sine to find the R and the U. That's all there is. Cosine takes you to the R. Sine takes you to the U. If you can remember that, writing your so ka up here will help you to see which one is which, because opposite is the U. Opposite of this origin is U, and adjacent is the R. That's all you really need to remember is these two in order to solve. Let's look and see if there's a next problem. All right, we get another one of these, but it's in a different quadrant. This one is going to be in the third quadrant. So let's just draw the third quadrant. All right, so this is 180. This is 270. We can agree that 180 or that 200 is between 180 and 270. So it's actually going to be more than 180. It's 20 degrees more than 180, right? Because I can subtract 180 from that and I get 20 degrees. So that means going past 180 by 20 degrees is going to take me where I want to go. And it has a hypotenuse length of 10, which means this is where that point is on my radar screen, right? So I draw relative to the x-axis a dotted line. This becomes it's not up, we're going down from the x-axis, so it's the opposite of up, which is down. And in this case, we're not going to the right, we're going to the left. And the left is the opposite of right, so negative R. So now we have so ka, right? So the opposite, or let's see, the adjacent is, I want the R first. So the adjacent is the cosine. So the cosine of 10 times the cosine of 20 degrees is equal to negative R. And I want to do the opposite, which is opposite 20 degrees. It's going to be negative U. So that's going to be 10 times the sine of 20 degrees is equal to the negative U. So now I just need the calculator. So I say 20 cosine times 10. 2 decimal places would be 9.40. Negative R. I transfer the negative to the value by multiplication of negative 1 times both sides. Negative 9.40 equals my R term. And now I do my U term. 20 sine times 10, 3.42 is my negative u. I transfer the negative to this side by multiplying both sides by -1 because we don't want a negative variable. So negative 3.42 is equal to u. And that's the reason why we use the negative sign here, negative u, negative r. It's if we use left and down, then we wouldn't have the negative sign. So our numeric value wouldn't be right. That'd be another step we'd have to take to transfer the L to a negative. And sometimes we'd forget, right? So it's easier to just say the opposite of right and the opposite of up to remind us to move that negative sign to the number. Now when we write this out, it's going to be negative 9.40 R minus 3.42 U, and that would be your solution. Let's look at the next one, if there is one. Okay, I actually think these are kind of fun. I'm a little bit nerdy, so, what do I know? All right, so what we've got to do first is we can't leave two different bases. We've got to have the same base in order to perform the calculation at all. So that's what we're going to do. 27 is 3 times 3 times 3. So we rewrite this as 4, the fourth index of 3 cubed, over the cubic index of 3. All right, now that they have the same bases, now we can draw a correlation. So we would say the innermost radical first, we have 3, and it is written to the 1/3 power. And around that, we have another radical, and we have 3 to the 3rd, and it is written, it includes, it's all inclusive. That's written one time, and we have an index of 4. So now we can multiply. 1/4 times 3, that's going to be 3 3/4. And 1/4 times 1/3, that's going to be 3 and 1/12. So in order to have the same denominator, we're going to multiply by 3/3. And that's going to be 3 9/12 times 3 1/12, which we know we can add now that they have the same denominator. That's going to be 3 10/12. But this can be reduced. So that's actually 3 5/6. That would be your solution. All right, so let's look at the next problem. All right, so here we are estimating. Remember, estimation is not accurate, it's just an estimate. So we're going to write this in scientific notation first because I don't want to deal with those really big numbers. So this would be 4. If I were to move my decimal point here, this would not round up. So 4 times 10, and that's going to be 1, 2, 3, 4, 5, 6, so to the 6th power. And this would be 7 because 1, 2, 3, 4, 5. So times 10, add 5 to that. 42 plus negative 42 plus 5 is going to be a negative 37. And 1, 2, 3, 4, 5, that 8.0 would not round up, so it'd be 8 times 10. We're adding 5 to that, so that's going to be to the 35th power. So I need to multiply here first. So I have 28 times 10. 6 plus a negative 37 is a negative 31 over 8 times 10 to the positive 35. Well, I can't have 28. I've got to move that over. It's going to be 2.8, which we would round to 3. We added 1 times 10 to the negative 30 over 8 times 10 to the positive 35. Okay, so now we divide. 3 divided by 8 is equal to 0.375 times 10. If I take this up here, that's negative 35, so it'd be negative 65. But we cannot do this right here. We can't have a decimal. So we're going to bring this back 1, so minus 1. And then 3.7 would actually be 4 times 10 to the negative 66. That's our solution. 4 times 10 to the negative 66. Now, if we had stayed here, if we had not rounded this, right, because of estimation, let's see what we would have gotten. 28 divided by 8 is equal to 3.5 times 10, and we've got, it wouldn't have moved this, so that would have been 31 and 35. So negative 31 minus 35 would have given us a negative 66, right? 3.5 rounds to 4 times 10, you would have still had negative 66. So you would have gotten the same answer either way. Either way. All right, next problem. All right, here we have to just find B. That's all we have to find. So the thing that I find easy, I've explained before, is to draw a separate triangle. So this would be A, this would be 4, this would be C, this is that internal right triangle. And I'm going to make this one big triangle like that. So then this becomes A plus B, and this becomes 4 plus 4, which, if we know what our addition facts are, 4 plus 4 is 8. So looking at this, from a base of 4 to a base of 8, I automatically identify my scale factor as 2, so times 2, right? So that means if 4 times 2 equals 8, then C times 2 is equal to 6. If I divide both sides by 2, C is equal to 3. So if C is equal to 3, then I can use Pythagorean's theorem to find A. All right, so I've got 3 squared plus 4 squared is equal to A squared. That's going to be 9 plus 16 is equal to A squared. 25 is equal to A squared. That means that 5 is equal to A because I unsquared everything. Square root of 25 is 5. So A is equal to 5. So now I can just use my scale factor and say that A times 2 is equal to A plus B, right? So A is 5. 5 times 2 is equal to 5 plus B. 10 is equal to 5 plus B. Subtract 5 from both sides. 5 is the value of B, which is what we were looking for. So I think you just have to type in the number 5. And that's it. All right, so let's look at the, oh goodness, tongue-tied there. Let's look at the next problem if there is one. All right, so we're going to find x in terms of y, p, and m. So again, this angle is equal to this angle. And we know for a fact that when we have two triangles bounded in a circle, that it creates this relationship. So P is going to be the same side as Y. And M is going to be congruent to or the same side as X. So here's our proportion statement, basically. Because this is one triangle, and this is the other triangle. This is one side, and this is one triangle, this is the other triangle. This is one side, this is the other side. So you keep your like things together, and you're always going to do a good job. So we have P times X is equal to M times Y. Divide both sides by p in order to find the value of x. X is equal to my divided by p. That is your solution. And actually, I'm not sure if it wants my over p or if it wants x is equal to my over p. So you try this first. If it doesn't take it, then do the whole thing. Next problem. Okay, so here we want to convert negative 3r, negative 5u to polar form. So both of these are negative, so they're going to live in the fourth quadrant. So we have, here's the x-axis and the y-axis. That's going to be the negative side of the x-axis and the negative side of the y-axis. So we're going to come over here, 1, 2, 3, and we're going to come, that's negative 3r. And then down 1, 2, 3, 4, 5. I know that's not, it doesn't have to be exact. That's where that point is. That's relative to the origin and the x-axis at the same time. So that's down 5 and to the left 5. But we know that when it comes to length, numbers cannot be negative. It's just their location that makes them negative. So this is 3 spaces to the left, and this is 5 spaces down. And this is our right triangle. So now we just have to find the hypotenuse that goes here, and then that will help us find the degree of measure for theta right there. So in order to find the hypotenuse, all we have to do is use Pythagoras' theorem. So 3 squared plus 5 squared is equal to, let's call this h squared. So we have 9 plus 25 is equal to h squared. That is 34 is equal to h squared. We take the square root of both sides. We know it's positive because a length cannot be negative. So the positive square root of 34 is equal to h. We don't have to simplify that. We can leave that just like it is. Okay, so this would be the hypotenuse that you would type into that first blank, square root of 34. Then you have that second blank, right? That's going to be your degree of measure for this. So we are going to use our so and our ka, just like we always do, in order to find the degree of measure, but we'll use the inverse of that. So we know we're looking for theta. So we want to find the r value. The adjacent side is 3. So we're going to use cosine for the adjacent. So that's 3 over h, which is the square root of 10. So the cosine of theta, which we don't know, is equal to 3 over the square root of 34. So we multiply both things by the hypotenuse of the denominator. We get the square root of 34 times, actually no we don't. I'm so sorry. We don't do that because this is our unknown. So what we're going to do instead is we are going to divide 3 by the square root of 34. So we need our calculator. Pull this out. So the first thing I need to do on here is to find the square root of 34. So 34 square root, right, there's that. Actually, let me start over. 3 divided by, now I'm going to use parenthesis, and then 34 square root of, parenthesis. That gives me 0.514496. That is my cosine of theta. This calculation gives me the cosine of theta. So now, in order to find out what that is, I'm going to use the inverse function. Cosine to the negative 1. So 59.04 is going to be theta. 59.04 degrees. And you know what? I only have to do one of those to find my degree of measure. I don't have to do another one. So 59.04 Actually, I take that back. So, yeah. This is 59.04 degrees, but this is 180. And I forgot about that. We went from 0 to 90 to 180, and now we've got another 59.4 degrees. So we have to add 180 to that to get the actual calculation. So this is 59, 5 and 8 is 13, carry 1. So 239.04. That is your degree of measure. Sorry if I confused you at all, but even though this is only 59.4, we have to measure from the x-axis at the 0 degree. So 0, 90, 180, plus another 59.04 degrees takes us all the way around to the full sweep all the way around our Cartesian coordinate system, which is 239.4 degrees. So don't forget that step. If you're getting the wrong answer, you know you've done this right, but you're typing it in, it's telling you it's wrong. It's probably because you forgot to include that other sweep or the other 180 degrees to your theta, to the angle that you found. So don't forget about that step. It's important, right? Otherwise, you're not going to be located on the system in the right place. Let's see, there's another problem. All right, we're going to find the volume of the prism shown. Dimensions are in feet. So here's the base, and here is the full prism. So what I have to do is find the area of the base. That's what volume is. Volume is equal to the area of the base times the height. That's all we ever do, regardless of what shape the base is in. So what we have to do is break this into something we can calculate. So if I do this right here, I can see that I have a triangle here and a rectangle here. So now I have A, B, C, D. So let's do A first. A is equal to a half circle, so half of the area of a circle, which is pi r squared, right? That's the first one for A. So that's going to be pi times 5 feet times 5 feet divided by 2. So I've got 25 pi divided by 2 feet squared for A. B is equal to a triangle, and I've got a height of 6 and a base. If we look across, this is going to be 8 because this is the same length as what's across the bottom. So this is a radius of 6, so this is a radius of 6. So we've got a triangle that is 6 foot by 8 foot, and it's a triangle, so we divide it by 2. That's going to be 48 divided by 2. That's going to be 24 feet squared. All right, so if we look at C, C is a rectangle, 6 by 8. So 6 foot by 8 foot, that's going to be 48 feet square. And now we have one more, let me write that one down here. One more half circle, so half of pi r squared. So we've got pi times 6 foot times 6 foot divided by 2, which is going to give us 36 pi divided by 2, so that's 18 pi feet squared. All right, so now we just add all of these together. So I am going to, actually I'm going to back up with this one, and I am going to add, and I'm going to say that this is 36 pi over 2 feet square, just so we have a denominator here that's common. It's going to let me add these two together. So 25 and 36 is 61 pi divided by 2. So I've got B and C makes 72 plus 61 pi divided by 2. All of that is feet square. All right, this is my area of the base. Now I'm going to multiply that times my height. So that's going to be times 8 feet. So I'm going to need my calculator for this. All right, so 72 times 8 is 576. And now I've got 61 divided by 2 times 8. So what I'm going to do is I'm going to say 61 times 8. This is 488. Now I have an even number. I'm going to divide that by 2. So that's 244 times pi. And all of that is feet cubed, because we have feet twice, feet a third time, feet 3 times. So that's how you want to handle this type of situation where you have a bunch of half circles and you get an odd number. Keep the denominator the same so you can add the numerators together. That gives you a number that you might be able to later reduce without a whole lot of, headache, because you've got an even number that you're multiplying by, right? That makes life a little bit easier. So keep that in mind. Keep the next steps that are coming up, what's going to happen later in the problem. There's an opportunity here that this will have a factor of 2 that will allow you to make that fraction go away and then have just a number times pi. So be thinking ahead, right? So we had the value of A, the value of B, the value of C, and the value of D that we kept in a similar format to A for the sake of being able to combine them using the rules of a common denominator, which is, one of the rules of fractions, which allowed us to have an easier time of it. All right, and that's all for this problem. Let's see if there is another problem. All right, so we're going to convert -4, -2 to polar form. Again, negative, negative, so it's in the third quadrant. So this is 4 from the origin to the left. So that's 4. And then we have, we'll say that's about 1, 2, 3, 4, right about here. And then 1, 2, so right about here. That's our vector. So over 4 down 2, because it's -4, so it's to the left. It's the opposite of right to the left, and the opposite of up is down. So over 4 down 2, left 4 down 2. So that is going to give us, this is our theta, which means we have to add 180 degrees to whatever theta is. We can't forget about that like we did last time. But we have the 2 sides of our right triangle, so we can use Pythagoras' theorem to find h, our hypotenuse. So 4 squared plus 2 squared is equal to h squared. We have 16 plus 4 is equal to h squared. 20 is h squared. So that's going to be 2 times the square root of 5 is equal to h. So that would be 2 square root of 5. All right, and then what goes in this blank is going to be the degree of theta, whatever this vector is here. So we can use, let's use cosine. So the cosine is going to be, cosine of theta is equal to, that would be ca. Adjacent is 4 over 2 times the square root of 5. So one of the things you can do when you have a square root, I know I didn't do this on the previous problem, but we know when we have a square root number here, we can transfer that. We want to conjugate that. So times 2 times the square root of 5, 2 times the square root of 5. So that's going to be 8 times the square root of 5 over 4 times 5, which is 20. So we know we can solve cosine of theta this way as well. So I'm going to pull that up and I'm going to open this. And first of all, I'm going to say 5 square root of times 8. Okay. Now I'm going to divide that by 20, divided by 20. That is going to be the cosine of theta. So I'm going to get the inverse of that. The inverse of that is theta is 26.57 degrees because we round everything 2 decimal places. So now that we have theta, right, we're going to add that 180 to theta so we know exactly where it lives in the whole sweep all the way around, right? So plus 180 is going to be 5, 7. This is going to be 6, and this is going to be 20. So 206.57 degrees is what that would be. So remember your rules of square roots, radicals, fractions, and how we can get rid of them. We could have solved it this way as well. We could have said, let me show you on the calculator right quick. We could have said quite easily 4 divided by, especially if you have a scientific calculator with parentheses, we could have said 5 square root times 2, close parentheses, equals. And then we would have done the inverse cosine, which would have given us the exact same number. It's just that when we conjugate and get rid of the square root in the denominator, it's easier to solve it when it's in the numerator. So especially, you don't have to go through all the steps on the calculator to use the parentheses and whatnot. All right. Either way, you get the same answer. So do the way. That's one of the things that I love about math is when there's multiple ways to do it and they both give you the same answer, you know that you're doing it right if you do it both ways. So do one way, do the other way. See what you get. Make sure they match. If they match, you're great, right? You're good. But also that gives us, a direction to the creator of the universe that all of it works the same way to give you a consistent answer. Man's just not smart enough to think that up, to put all those rules in place. We were on purpose. This whole thing was on purpose. And just math just solidifies my belief in that. That's why I love it so much. Let's see if there's another problem. All right, so we have conversion of 40 inches per second. So 40 inches per 1 second. And we want to go to meters per hour. So we need to go inches to meters. So that means we have to go inches to centimeters first. So 2.54 centimeters is equal to 1 inch. That cancels inches. Now we know that 1 meter is the same thing as 100 centimeters. That cancels centimeters. Now we're in meters, so now we have to go to hours from seconds. So we know that 60 seconds is the same thing as 1 minute. That cancels seconds. And we know that 60 minutes is the same thing as 1 hour. So that cancels minutes. So now we just rewrite it. 40 times 2.54 times 60, we could say squared, and that is in meters over 100 hours. That's it. That's our solution. All right, and if it won't take the exponent, if you type this in and it does not give you the right answer, you could also try 40 2.54, 60 meters over 100 hours. Sometimes, I think usually everything in the denominator is going to be in parentheses. So this way or this way. I think I may have both of those in there. If not, just try the other direction, the other one with or without the exponent. And one of them should be marked right. And if there is an error with that, if both of those are not accepted, let me know which one it doesn't take, and I will fix that. I'll add both answers in there because both answers are correct. Let's see if there's another problem. All right, so here's another one of these. These should be getting easier for you now. We start with the innermost. Both of our bases are the same. They both have an exponent of 1. This should be 3, the square root of 3, and then 3 with an index of 5. So 3 1/5 times 3 1/10. We multiply this by 2 over 2. We get 3 2/10 times 3 1/10, which gives us 3 to the 3/10 power. That's our solution. Easy peasy. Next problem. And that is our last problem. Yay! That was all we had in the last request. If you have any more questions, please feel free to ask. You have 5 more days. 5 more days to get everything that you want to redo redone and bring up your grade for this semester. And after that, grades are finalized. So take advantage of the next 5 days. What are you doing anyway besides sitting at home and playing with your Christmas toys? Or outfits or whatever it might be. So I will see you next semester. I hope you had a great Christmas. It's the day after Christmas, by the way. I hope you had a great Christmas. I hope you got to spend time with people that you love and people who love you. And I hope that you really, truly understand what Christmas is all about. It's not about the gifts. I do hope you got some good stuff. But I hope you got better stuff in your relationships with your family and the people that love you. And that's all I have for now before I get too mushy. I'll see you next semester. Bye.